Okay, so your homework, I'm live streaming right now, by the way, so your homework is to go over automatic control input for completion grade. And then just go through it, take a quiz. You don't do good on it, that's fine. I'll take a completion grade on it. I'm taking up the grade on the reversing section that we're finishing up today on Monday. So I'm going to take the final grade on that Amatrol section Monday. Also gave you a skill that I want you to complete. Let's go over that. Design and overhead.
We know that.
And under this one, this is available online. This is primarily for the two people that aren't here. Basically, you're going to design a control circuit. You don't have to wire it up. If you choose to, this is skill 2 out of that next section, automatic device inputs, I believe is the name of it. Let's make sure. Device 1, I wrote it down and sent it to you in a text. But you're going to do a door, automatic garage door opener. So I want you to think about this. It goes through here and it lists everything that you're supposed to be doing to draw this ladder logic circuit. Okay. You push a button. Let's see. Motor must be able to run in both directions. What kind of contactor do we need? See, forward, reverse. It wants you to use a control transformer. Here's the operation. Momentarily pressing one push button will cause the motor to run in the forward direction up until the stop button is pressed or the door reaches the end of travel in that direction. And then the exact opposite on the number 2 push button will be down. You must be able to push the stop button before you can change direction. Limit switches will be used to sense the over travel of the door in either direction. If over travel occurs in either direction, you will only be able to operate the motor in the opposite direction. That's probably a hint you need to pay attention to when you draw this. And then, of course, auxiliary contact and mechanical interlocking should be used to protect the motor and starter. What type of circuit does it sound like? The same one you just drew in your quiz, except you're going to put 2 limit switches in it to prevent it from over traveling. So if you go online and do the simulator, they got all the contactor and they got a garage door with 2 limit switches and a motor, and then the garage door actually open and close. So if you want to do it online, you can. When we come in here, we'll actually hook up the circuit. I don't know. We should have enough. We might have to pair up. I don't know how many limit switches I have ready to go, but some of you might get a float switch. You won't know any difference. There's a limit switch on it. You'll have a little floating bobber. That'll cover the second part about float switches. Or some of you, we got proxies. I know we'll use a prox instead. So either way, we'll work on that circuit when we come in next time. And that's your homework for next time. So you're clear on that. Today we're going to go through the second part of this section. And when we go in there, I'm going to have you continue working on the forward reverse. I want you to be able to do this, hopefully from memory. Walk up there and just do it. You get really good, you don't need to print, but at least, be able to draw out a print, wire it up. So that's what we're going to do on this next one. And then I'm going to begin testing you out on the start-stop. We'll set up a little camera. I'll bring my laptop in there. One at a time. This will take several class sessions. Those of you that are comfortable with doing it, I'm going to film you. You're going to put on your arc flash. I'm going to go through there. Well, your arc flash when it's hot. You're going to wire it all up, start-stop. You're going to draw it out, wire it up, show the camera, and then I'll put in 2 faults. You'll troubleshoot them
In front of the camera.
in front of the camera. Okay.
It's not very nice.
And then each one of your groups of your maintenance guys or whatever, I'll just send a private link to them, and then you get out of here and they hand you a motor contactor and you go, I don't know what it's for, and they send you out there to wire it up, and you blow it up, and they come back and say to me, and I said, well, did you watch that late? Because he did it in class.
Say union steer.
So that's what we'll do. It just looks good for employers to see that there's actually, here that is, they did learn something. It's on video. We know they're doing it because they're not in the classroom with us. So we want to try to promote this and make sure that we're following things that they should know in the workplace. Okay, I turned the camera off and we're just recording what's on the screen and audio. So, yes.
I was just trying to get on here. Won't let me log in now.
Oh, it won't? Yeah.
This is my password.
Or you'll have to change it.
I'll do it. For what? Whatever.
Whatever you want. At least we all have to.
So we reset time limit. It's not that big a deal if you're logged in. We're not going to really go through the skills. I'll be honest with you. Most of the rest of the modes of operation, I really want to talk about it, and we'll look at it. But I mean, there's a jog function with reverse. We've already done that. You're doing the skill troubleshooting in there, so if you just want to watch me, it's fine. Handoff automatic control. I'll be honest with you, when we start adding these auto manual features to a circuit, we're not going to hardwire them. More than likely, they're going to be hooked up to a small PLC. The logic will be in there, but it'll be in the PLC. You're going to wire it up. Anything more complicated than a start-stop circuit, maybe with a limit switch like on a door. Anything more complicated than a roll-up door, probably going to have a PLC on it. To be honest with you. If there's any kind of time delay or anything like that, we'll go through ice cube timers and stuff. So, anyway. Okay, typically a system has a couple of modes. We got automatic mode, manual mode. Everybody knows that, right? Some of you might not, but automatic mode, basically you're going to do some kind of step and then stop, or do a continuous cycle. The machine will continue if it completes its task or receives a stop input. The normal operating mode for most machines, of course, is the automatic mode. A common application is a washing machine. Goes through a set of steps. Has anybody seen what controlled the washing machine 20 years ago, 25 years ago, what the knob looked like on the back of one? If it went bad, it was an electromechanical device with a bunch of tiny limit switches. As it run through there and you pulled the knob out, it did something, or you pushed the knob in, and basically it was an electromechanical rotary type system. And basically, if it went bad, you might as well get a new washing machine because it's cheaper than trying to buy that switch. Now we probably have tiny PLCs hooked up to our washing machine. Yeah. Wash gas.
Oh, yes.
It won't run good if it's got water and gas.
Kickstart.
So
With a hand crank.
with your hand.
Yeah.
crank.
Hand crank, whatever.
We'll have to Google millennial here. Manual mode. In manual mode, a person can operate each part of the machine separately or step the machine through its sequence one step at a time. These are used with inputs of manual push buttons. Like I said, typically whenever we get something with manual and auto modes and stuff, if it's anything more complicated than, say, for example, we run a machine and we run it until it reaches the end of travel and we shut it off in manual mode, we hold the button and just run continuously. Does that make sense? So in our door example, we would have if we were to say that in automatic mode, it would stop the limit switches, but in manual mode, I could just run it until it tore up. That's not always the best deal for a machine either, to give the option for manual control that can tear it out.
So it's similar to a job. You hold the job button down and machine will run until whenever.
Yeah, till it breaks or gives. So a lot of times they do that for clearing jams and some kind of process, feed process. That could be good or bad. Hopefully the overload strip before it tears up something. A selector switch is often used to allow the operator or technician to change from one mode of operation to the other. The manual mode is often used during machine setup and maintenance. It would be dangerous to try to adjust or repair a machine while it is in the automatic mode. Core. So typically we'll have a manual auto switch for those type of functions. You might even have, if you wanted to save buttons, you could do a circuit with a automatic mode that runs all the time and then a manual mode jog. You could do a circuit like this.
We got a selector switch on machines. Strip machine out. You know, it'll run there for wire breaks or anything.
What now?
Some of our machines have a number of buttons. Some of them select a switch, put it on strip mode.
Yeah.
The strip on the machine out.
Yeah.
Everything else to go to the different product, different size, whatever. The wire breaks. It shuts off all the brake arms and stuff. So it'll just run until
You don't care, yeah.
Pull a wire part inside the machine, whatever.
Yeah. Let's reiterate. In manual mode, there are no automatic stop features, typically. Okay, unless there's something to do with safety, like a door switch tied into the e-stop circuit. But something that's not going to cause a safety issue, typically in manual mode, it runs regardless. And a lot of times, manual modes for maintenance to be testing stuff, bumping motors, and everything like that. For example, if we did a simple little circuit here, and we start-stop station, we come over here to our motor with our overloads, and then we would come down here and we would say M aux. And we come over here with a showing the default position, auto, but if I turned it to the right, we'd be in manual, and what would that make that circuit?
We just make it shut off. No.
Well, this was just a start-stop, right? So if I turn this and this opened up, what would that now be?
Jog?
It'd be a jog.
Why didn't we do jog like that?
You'd have to hold down the button, right? Just to get it to go.
Because I wanted you to use a separate jog button. That's how you'll see a lot of jog features like that, where they'll just break the aux with a selector switch. You put it, they might be auto manual, might say jog mode or something like that, run or jog, whatever.
Inch.
Yeah, inch, different things. This would be run or jog, but basically that would be that. So we could also do this. What if we wanted to add another auto feature here? Running out of room here, but we'll see what I can do. And we added like go back over here to make it. Call that one. I'm gonna draw it down here. So whatever reason, this switch would be normally closed. A limit switch there. It was a travel stop. So in auto mode, you hit the button, it would run to the end of its run, it's turn off. Okay. But in manual mode, it would keep running. Okay. This might kind of give you a hint for your homework too, by the way. That would not, well, not exactly like that. Anyway, so those type of situations, little stuff you might encounter that it's actually hardwired. Like I said, most of the time, if it's going to be a large machine, we're going to do a PLC or a small programmable relay, which is a PLC on the circuit. So here's jog mode operation. I think we've got that down. Let's go to the next objective. What are they talking about here? All right. Click on each type of motor jogging circuit for more information. Let's look at this one. All right. So this is circuit in run mode. This is the stop button. And then they lock out the stop button. I've never seen this because most of the time when you provide a lockout for an e-stop, the machine shouldn't run if you push the start button. So if you make this would be a machine stop, it wouldn't be an e-stop. But this would be, say you had a push-pull mushroom head or something. That would be a safety issue. So you probably don't ever see a circuit like that. But they listed it. Then we would have what I just showed you before with this simple jogging circuit here. So, same principle is what we did before, breaking the latch there with the jog. When we hooked it up before, I made you add a separate jog button. So. Everybody understand how that circuit's working? There's no confusion about that, what we just drew on the board. No, I'm not going to do that. No. Describe the operation of handoff automatic motor control. If we have a 3-position selector switch being the neutral position, you're going to have that, neutral position being nothing connected, so you're going to have a 3-position selector switch on these type of circuits. If we had manual mode, for example here, when the selector is placed in the hand position, the coil to the motor is always energized. This means that the motor will run continuously. So when they put it in hand mode, they're bypassing the button, just turning it on. You probably won't see a lot of those. You would probably for maybe a sump pump or some kind of pumping application. Definitely not something anybody can get their hands into because that would be, we don't like non-restarting circuits, but if it's an application where you needed it to run all the time, maybe you had a pump, you tried to pump a tank out and didn't want to worry about the limit switch, wanted to pump it as low as it'll go, you'd put it in hand mode and let the pump take over and pump the tank out. In auto mode, it looks at the limit or the flow switch.
Basically manual, same thing.
Yeah, except if the power goes off and comes back on, guess what? It takes right back off running again.
Right.
And in a sump pump or a pumping, that might be something you want.
Right.
Okay. But you need to worry about safety concerns with something else. It depends on what that motor's running. If it's running a pump, probably all right. It's buried in the ground. Everybody get to it. If you're running a conveyor, that's a bad idea. Off mode, of course, in this position, nothing runs. And then in automatic mode, we would put it in auto mode. When the auto is placed in the relay, the circuit will rely on the input devices to energize the coil. So in auto mode, we would probably say, let's see if they got an example of the limit switch on here. They didn't put one in there. No. So, for example, this is showing an input device here, and that could be what? What kind of input device could that be? Could be a Could be a limit switch. All right. Could be a float switch. No, that's not good. That's not great for today. But anyway, it could be different types of switches there to run it. It could be a level switch, float switch, etc., etc. So it'd be some kind of feedback device, okay, which we're fixing to get into when we start talking about automatic and manual. And the next one, when we start talking about sensors. What do I mean by a feedback device or control device? Well, let's back up. A feedback device typically tells me something happened, right? What is an auxiliary? Auxiliary latching connect. What type of device is that?
Switch.
It's a switch, but it's a feedback device that tells me that I push the contactor. It's only being used, and so it closes and it feeds back. In a PLC application, we would tie if you wanted feedback from a motor that it actually started, you would use that aux, and instead of tying it into a start-stop circuit, you would tie it into an input on the PLC, and then the PLC would see that I sent a signal out to turn the contactor on. It closed and sent a signal back to me that said it did close. We're good. We'll keep running the motor. Does that make sense? If I lose that feedback while the motor is being told to come on, then I know it tripped because the overload's tripped and dropped out the relay. So then I would use that for a feedback device. Make sense? Now, pilot operated device would be like a push button, limit switch, something that turns it on. Anyway, we'll get into those sections later on. I don't want to go too much in depth on that today. So that brings us to the end of this section. Let's look and make sure. I'm going to take a quick look at your homework. Make sure you understand that. I know we did that at the start, but I'm going to show you while I have you here. Pull up the. I thought it was pretty cool when I saw it. I looked at that exact skill set or skill module. So I thought we would. So. So I mean, some of these, when you go through here, you can do the skills, but this one actually, let's go to this skill 2. Connect and operate electric. It's going to explain to you how it works there, and then on your simulator, there's your dual. And you've got these little limit switches right here that you'll need to connect to. You want to do that. Now, one thing I want to point out on that, there's some designators on these points for C, NO, and NC. Are you with me? So what does C mean? Common. Okay. And so basically, if you were to look at the inside of these contact blocks, say we have a limit switch and be something like that, and in its normal position, this would be the common, this would be the NC, and this would be the NO terminal. And then when you actuated it, it would flip over. And so when you flipped it over, it would go here to the closed position. That makes sense? So what they're saying is this is labeled in the default position here. And so your actual circuit right here, in this state right here, if I were to ohm out between these 2 points here, right here, and here, I should read 0 ohms of resistance, unless the door is all the way up, then it'll open. Kind of depend. Is it normally open, held, closed? Normally closed, held, open? We don't know. You just have to hook them up and see. If it don't work one way, what are you going to do?
Switch reverse.
Just take the wire wherever it was on the NO, or move to the NC, or take it from the NC to the NO and make it work. So that's all you got to do.